Okay, chapter 6 is probably the funnest and most applicable chapter so far we've done. Standard and let's see, standard normal distribution. So z-scores. Z-scores are a big deal. So you've got your mean and you've got sigma. Now z-scores, here's what you got to remember. So instead of looking at the tables that they printed out and gave to you with the tests, the calculator can do all the z-scores. So z-score happens right here when the mean is 0 and standard deviation is 1. So if we put the mean at 0 and go 1 standard deviation, 2, 3 standard deviations, and go left 1, left 2, left 3, there we go. And these are z-scores. So z-score is just how many standard deviations you are from the mean. Okay, so your calculator, if I go menu 6, it's a distribution, we're going to go 5, or you can go menu 5, 5, inverse the normal, so 3. And it's already defaulted to give you a z-score. So the mean is 0, standard deviation is 1. If I want to know the area of like the 25th percentile, so 25%, so here's what this means. Okay, so 25% is negative 0.67. So what that means is this. I am going to go, my z-score is negative 0.67. So from the mean, I'm going to go left 2/3 of a standard deviation. Now that point right there, everything to its left, that accounts for 25% of the graph. And this comes in handy when you want to center this percentage on the middle. So for example, let's say that I want the center 25%. Okay, so I want 25% of the center. That means this. That's 0. I'm going to go 12.5% to the right and 12.5% to the left. Okay. Very good, very good, very good. And that should give me 25% centered around the mean. Okay, now, so that's 25%. That means from here to here is 25%. That means out here is 75%. So I got to do 75, and I'm going to divide it by 2. So 75 cut in half, and those are going to be the tails. So on each tail, I'm going to have 37.5, 37.5. Okay, now, I need actually to use this 37.5. And that is what I'm going to use. I'm going to calculate this area right here, 37.5. So on your calculator, we're going to do the same thing. So menu 6, 5, 3, inverse normal, the area, 0.375, the mean of 0, standard deviation 1. Okay, I've got to go a negative 0.32. So here is, I guess it's going to be more like right here, negative 1. So I'm going to go negative 0.32, so not even half of a standard deviation. And I'm going to go that much to the left and that much to the right, negative 0.32, positive 0.32, and that will give me 25% centered on the mean. So z-scores are kind of cool, and the calculator is much easier than looking at those tables. This is, you need to know this. To find the z-score, you just take x minus the mean divided by the standard deviation, and pretty straightforward stuff. So this is good. The z-score happens, it's a normal distribution, the mean is 0, standard deviation is 1. So let's put it into practice. Okay, a bottle of water contains 12.05 fluid ounces with the standard deviation of 0.01 ounce. Define the random variable x. Okay, your random variable x. So you're doing a bunch of sampling, you're measuring bottles, picking out random bottles from the production line. X is measuring fluid ounces. So 12.05, maybe you grab one and it measures 12.55, maybe it measures 11.86. But these numbers are fluid ounces. So that's what it is. Normal distribution has the mean of 61, standard deviation of 15. So if you're looking at normal distribution, the mean is 61, and I'm going 1 z-score to the right is 61 plus 15. So it is 76, and then if I do plus another 15, that's like 91. That's 2 z-scores. Okay, the median is also the mean. They're the same thing. That is the dead center. If it is a normal distribution, a normal curve, the mean and the median are the exact same value. They are the dead center. Okay, number 3, so x has a normal distribution. That's what the n means. And this, you remember, this is the mean, this is sigma. Sigma is 2. Number 4, company manufactures rubber balls. The mean diameter of a ball is 12 centimeters with a standard deviation of 0.2 centimeters. Define the random variable x. Okay, it's just like fluid ounces. X is measuring, so you're making a bunch of rubber balls, you grab a sample, measure the diameter. So x is these different measures of diameters. So you're gonna have a bunch of different measures depending on how big your sample is. If you grab 50 of those balls off the line, then you're gonna have 50 different measurements. Okay, 5, x is a random variable with a normal distribution. The mean is -4, standard deviation is 1, the median, that's -4, it's kind of the same thing. 6, sigma is 5, 7, mean is -2, so these are pretty basic, pretty easy. What does a z-score mean? Z-score is how many standard deviations you are from the mean. Okay, now these are better questions. These are probably more closely what you're going to see on a test. In 2005, 1,475,000 students heading to college took the SAT. Distribution of scores in the math section of the RSAT follows a normal distribution with a mean of 520, standard deviation of 115. Calculate the z-score. Okay, that is this guy right here. I'm just going to use this formula. To calculate the z-score, if you've got the mean and the standard deviation, some kid scored 720, so this is just one person's score. So that is x. His score is 720. So I'm going to take 720, subtract the mean, which is 520, and divide that, so it's like 200. Divide that by the standard deviation. Divide that by 115. And what do we get? We get like 1.74. So that means he is living almost 2 standard deviations above the mean, which is pretty significant. He's in a pretty good spot. He's a pretty smart dude. What math SAT score is 1.5 standard deviation? Okay, this was 1.75. So 1.5's got to be a little smaller than 720. Okay, so here we go. We're just going to take that 1.5 and I'm going to times it by the standard deviation of 115, and that is going to give me 692.5. That's It's pretty reasonable. We knew it's got to be less than 720. 720 gives us 1.74. So to find it, that is the z-score. Z-score is 1.5. So you just multiply it by 115, or by the standard deviation. Okay, C. For 2012, SAT math test had a mean of 514, standard deviation of 117. ACT is a similar test with a mean of 21, standard deviation of 5.3. One kid took the SAT and got 700. Another kid took the ACT and scored 30. Who did better? Whoever did better is going to have the larger z-score. A z-score of 1.74 is much better than a z-score of 1.5. Okay, so here we go. We're going to take the score, okay, 700. So we're going to go 700, subtract the mean, what is the mean? Mean of 514, divided by the standard deviation, 117. Okay, that gives me a z-score of 1.59. Now we're going to go ACT. ACT, you do that score, this is x, subtract the mean, 21, and divide that by the standard deviation, divide that by 5.3, and this guy is 1.7. Okay, so this guy's smarter. He did better. He is further away from the mean. The farther you are away from the mean, on scores, test scores, if you are to the right of the mean, so the mean is the dead middle, that's the median, that's average Joe. If you are to the right of average Joe, 1.7 z-scores, you are in good company. You gotta remember, 3 z-scores above and 3 z-scores below, that captures 99.7 of all the population in the whole world. This dude lives 1.7, so he lives he lives right here. So he's in almost elite company. Okay, so now using the normal distribution. God, we're pretty good at this. This is all calculator stuff. So, for example, use the following information. So you got a normal distribution with a mean of 54, standard deviation of 8. Find the probability that x is greater than 56. So if you're looking at kind of a picture, 54 plus 8 is going to be 62, plus 8 is going to be 70, plus 8 is going to be 78. Alright, so find the chances that x is going to be somewhere bigger than 56. So 56 is like right here. So they want the area under the curve from 56 and above. So we are just going to go menu 6, 5, and that is any area under the curve. That's going to be a cumulative distribution. So we're going to go normal CDF. The lower bound, we're going to go 56. The upper bound, we can put in some big number, 100. As long as you get it out past that third standard deviation, I think that third one was like 78. Get it clear out there so that you know you're going to capture everybody. Okay, the mean. Let's see, where were we? So the mean was 54. Standard deviation was 8. Hit OK, and this will do it all for you. So that is 40%. So the area under that curve, that is like 40% of the population. So find the probability that it's under 30. So 30 is clear over here to the left. It's a negative z-score. So we're going to do the same thing. I'm just going to change this. If I go under 30, calculator froze up. My keyboard's froze up. Something's froze up. Okay. Let's just go escape. We'll just start fresh. Menu 6.5. Normal CDF. We're gonna go, where are we going? 0 to 30. Mean of 54. Standard deviation of 8. Paching. Okay, so that's really small. 0.00, not even 1%. So if I move that decimal over twice, it's 0.13 of a percent. So that's pretty small. 0.13 of a percent. Okay, let's look at 52. We'll skip 53. They're the same thing. If you can do 53, if you can do 52, you can do 53. Find the 80th percentile. So it wants to know, you got a curve here, boom, it wants to know pretty much here to the left. The 80th percentile, that's like that guy in the ACT, is pretty good company. So we're going to inverse the normal. So we're going to go menu, 653. What was the percent? 80th percentile. So we got to type in 0.80. Type it in as a decimal. The mean is 54. Standard deviation is 8. And paching. So 60.7. So that is like right here. From here on out. And that totally makes sense. So the 80th percentile, you know 50% live to the left and 50% live to the right. That captures everybody. So here's the dead middle. And this one standard deviation is 34% of the population. So 80th percentile is not even going to be one standard deviation above the mean. So that's perfect. Okay, and this is what I'm talking about. So the empirical rule says standard deviation is 20. Oh, no. Mean is 20. And standard deviation is 4. So we're going to go 24, 28, and 32. We are going to go 16, 12, and 8. Okay, so here's what you got to remember. 34% and 34% live there. So between here and here, that is 68%. So A, we got A done. A, 68% is going to be between 16 and 24. And now from here to here, you got to remember that is 95%. And I can never remember how many live here. But if I know that's 95, I'm going to take away 68. So if I go 95, take away 68, and if I divide that by 2, if I cut that in half, that means, okay, each one's going to be 13.5. So I'm going to go 13.5 there, and 13.5 there, and we're going to answer B. So that they fall somewhere between 12 and 28. Well, that's about a 95% chance. And then C, there is about a blank chance the number is going to be between 8 and 32, and that is, if we go 3 standard deviations to the right, 3 z-squares to the left, that captures 99.7. Captures just about everybody. Okay, last one. Facebook provides a variety of statistics on its website that detail the growth and popularity of the site. On average, 28% of 18 to 34-year-olds check their Facebook profiles before getting out of bed. Suppose this percentage follows a normal distribution with a standard deviation of 5%. Alright, so it's a normal distribution. The mean is 28%. Standard deviation is 5%. There we go. So find the probability that the percent of 18 to 34-year-olds who check their Facebook before getting out of bed is at least 30.
So at least 30, it can be bigger, but it cannot be smaller. Greater than or even equal to 30. So here we go. We're going to go menu. Whoops. Menu 6.5, and that is a cumulative. The lower bound is going to be 30. The upper bound is going to be 100. The mean is going to be 28. I think if you change all these to decimals, you should get the exact same answer. What was our standard deviation? 5. So if I run that, we're going to get 0.3446. So that is about 34.5%. So this is kind of weird because it's percent, it's talking about percent, so it's kind of confusing. So it's really kind of a poor question. Find the 95th percentile. So the 95th percentile, that is going to be menu 6, 5, 3. We're going to inverse it. So the 95th is 0.95. The mean is 28. Standard deviation is 5. Okay. So that is 36.22. So if my mean what was my mean? 28, and we're going by 5s. So 33, 38, 43. Okay, we want 95th percentile, so this, okay, that's 50, that's 34, so that's 84, and that's 13.5, so it's got to be somewhere in here, just guessing, and the calculator tells us that it's got to be 36.22, so we're spot on. 36.22 is like right here, so everything to the left of here, that accounts for 95% of the population.